the entire decentralized AI build-a-thon. So, as many of you who are here, I believe you already registered to the decentralized AI build-a-thon. It is an build-a-thon that Aspecta is hosting with Near from May 17th to June 24th. It's a month-long build-a-thon that we want to push the boundary forward for the crypto AI space, which if you have any innovative ideas, any project you want to build within the crypto AI space, definitely submit your project by our deadline in June 24th. And we have a large prize pool for those of you who are building great project. And Aura is also one of our sponsors for the decentralized AI buildathon. And Aura also put up a bounty worth of 3,000 US dollars for the buildathon. So if after our workshop today that you found technology with Aura interested and wanted to build something with the IMO framework or any tech set that MSView is introducing today, then definitely feel free to build those projects and win the bounties from Aura. And for today's workshop, we have MSView, the research engineer from Aura, to introduce us on how to build an on-chain AI with Aura protocol.
All right, awesome. Thanks for the intro, and let me get started. So I am learning from Aura, and at Aura we are building an on-chain AI protocol, also the verifiable Oracle protocol, or a verifiable and a trustless AI product. So today I will be talking about how builders can build with Aura's on-chain AI Oracle product. So today we will be talking about the Aura's on-chain AI tech stacks, and also we will take some of the great examples from our community to talk about some existing projects that is already building on Aura ecosystem, and like draw some inspiration for them so that we can builders can build know what they're gonna build based on the existing examples, and also maybe have some more imagination on building something exciting and something new. So let's get started on the Aura's on-chain. So to talk about on-chain AI first, we need to make sure that we are clear on the terminology. So when we are talking about on-chain AI, we are actually talking about on-chain AI inference. In the life cycle of machine learning, it actually has two major phases. The first one is training, which is like taking a lot of data and then taking a lot of GPUs to train this AI model into a final runnable model. And inference stage, the other stage is that you have this model already and you deploy it somewhere. Let the server to run the inference to kind of helping people to predict their next output. For example, you deploy the ChatGPT model on the one of the server, and then you set up the front end. Then every time people are interacting with the ChatGPT model, it's actually kind of generating this inference result for the next token of the large language model. And right now, we see that the AI inference is more practical for being on-chain because it is minimum computation compared to the training. Because I think you already heard of people spending millions of dollars to just train one probably like medium-sized model. And so training actually takes a lot of the resources to perform. But for on-chain AI inference, it is more practical because AI inference is a little bit less expensive and less taking less computation resources. so that we are focusing on this part of compute of the AI lifecycle. So in terms of on-chain AI inference, we actually have these three different technologies at ORA. And right now in the industry, we see a lot of ZK-ML approaches to achieve on-chain AI inference. So ZK-ML is actually kind of similar to the ZK rollup, which is you generate a cryptography proof of something, of some computation, and then instead of like running the whole computation inside a smart contract, you have you verify a cryptography proof inside a smart contract. And this cryptography proof is easy to verify because it is like very succinct, and also you can just having those like multiplications and all that cryptography operations to compute out whether this like magic proof is correct or not. So if the proof is correct, then you can make sure that the computation behind this cryptography proof is correct. And then it is widely adapted into the spaces of like rollups. So they are building something like ZK EVM or ZK VM. They essentially build a virtual machine or an execution environment for these type of running, like executing modules, and so that any compute that is running inside of it will just like generate a proof. Then this proof will be verified on layer 1 blockchain like Ethereum. So in the early days of on-chain AI inference, ZK-ML is very much like a dominating solution because it is like having this ZK-ML framework similar to the ZKVM, and any computation that is running inside of it will just having this ability to be verifiable because you can verify this proof. But in terms of the disadvantage of ZK-ML is that it is already kind of expensive to generate the proofs for EVM, like the EVM computations. But for ML inference, they are like more, they are kind of a more resources intensive computation that requires more like beefy servers and all that. So one thing about ZK-ML is that the proving overhead or the proving generation time is super long. Like for example, if you want to run a GPT model, like GPT-2 model inside of it, you actually need to wait for like 200 hours for the proof to be generated, so that it is like basically impractical. Because for example, if you just wanna like having this kind of AI to examine if this transaction is safe or not, and then you need to wait for like 200 hours, then it will be just like too long. So this is one of the problem of ZK-ML. And at Aura, we actually built one of the first ZK-ML framework called Kairos to Circum. It is one of the first, and it is adopted by like projects from Ethereum Foundation and a lot of like hackathon winning projects. So to solve the problems of ZK-ML for having this kind of super long proof generation time, for having this super long latency, we invented a framework called OPML, which is optimistic machine learning. It's basically taking inspiration from the optimistic rollup. So because ZK-ML is already kind of borrowing the idea of ZK rollup, then why not we just using the same idea of optimistic rollup and take that into the ML inference space. So what OPML works in one sentence is that they assume that all the ML inference or the computation are correct until someone proposes a challenge, and if there's a challenge, we're gonna settle it on the Ethereum layer 1 or inside any layer 1 smart contract. We're gonna get to more detail about the OPML, and OPML is the technology that we use in our AI Oracle, which is the kind of the main character of the talk today. And we also got OPI. This is another like an endgame framework that we invented. So OPI is called Optimistic Privacy Preserving AI. It is mixing the OPML and also the ZKML. So OPML requires the model to be fully available or to be fully open source, so that anyone can run it to detect if challenge is needed. For example, like if someone is executing with the bad program, and then they having like a different output, then someone needs to make a challenge. So the model needs to be public available so that anyone can run it. And for ZKML, it actually comes with the feature of ZK, the knowledge, which is privacy. So one thing about the OPML is that it needs to be public, so that it doesn't have the privacy in terms of the model. So like some of the company, for example, maybe you are a financial company and then you want to keep your ML model to be private because it contains like the trading strategy, like the key value of your company, so that you want to keep the privacy, then you can use OPI. So basically what OPI does is that it combines OPML and ZKML together, and it will let part of the model to be public, and then the other part of the model to be in ZK, so that you can keep some of the model to be in privacy, and then no one can like know the whole detail about the model, but it still like gets all the scalability advantage from the OPML. So these are the three tags of ORA's on-chain AI. And then we were gonna do a deep dive into the OPML. So as I said before, OPML is more scalable than ZKML, and it makes on-chain AI a reality. So optimistic machine learning is more performant, practical, and also with OPI, it is privacy preserving. So for more detail about OPML, you can look at this link. It has all the paper and all the academic like format of the description of OPML. So you can take a look at this for more detail. OPML, so one thing about the ZKML is that it has a proving overhead, right? For example, like the 200-hour proving generation time example, in terms of the index of this proving overhead, we can say that if each executing program is like taking 1 unit of time, then like generating a proof for it will at least take like 200 or like to 1 million overhead of time, so that it always has this overhead that you can never overcome. If you like use up all these techniques for optimization in terms of like software, you have the most advanced ZK framework, like for example GKR prover or like Binance or something like this, or the advanced framework to optimize it from the software level, and maybe you have this ASIC chip for the prover, and then all these optimization combined together, you will still have this overhead. But it will just lower the number a little bit. Like for example, you can lower it up to like 10 units of time, but it will always be easier. And for OPI, for OPML, it is like having no overhead because it is like optimistically assume that this computation is correct. And then since it is correct, we can just let the native execution or just the proof execution to be passed, to be verified as true until someone is proposing a challenge. So this nature is making OPML the practical way to make on-chain AI a reality, because what it means is that you can literally run any model on chain, because anything is in their native speed. You don't need to wait for any proving generation time until someone proposes a challenge. So let's go into how the challenge process works and what are the key components of OPML. So we know that there's a challenge system, and then there's a fraud-proof system mechanism of OPML or the ultimate roller. So the key components of OPML is these three. So the first one is the fraud-proof virtual machine, and the second one is on-chain VM, and the third one is fraud-proof system. So the fraud-proof system, you can think of it as a kind of cryptography system that you can run any compute and resolve any disputes on chain with a set of algorithm that locates the dispute and then resolve the dispute on chain. For fraud-proof virtual machine and on-chain VM, they are actually running the same computation, which is the challenged computation. For here, if someone is initiated a challenge, then this will be run inside the fraud-proof virtual machine and also the on-chain VM for a correct result. And also running this fraud-proof system to locate which part of computation is correct. For example, we got in one computation, we have 3 steps, like step 1, step 2, step 3. And in the step 2, the dispute happens, or the two nodes having different computation outcomes. So it leads to that the step 3 is different. And then when one of the nodes proposes this challenge, this computation will be run inside the fraud-proof virtual machine first to make sure that these challenge is reasonable, and then they will be taken to the on-chain VM. So it's basically a smart contract that runs the step 2, which is a very tiny part of a computation, and then this will be resolved if and to find out whether the challenge is correct or not, or then the node that is doing run, probably they propose a wrong challenge, or the original node that compute with the bad output will be slashed. So this is basically how it works. And this is actually more about the crypto economic mechanism of making sure things are working correct. And ZKML is actually more about having this cryptography system to making sure everything is working correctly. So it is a little bit different, but these two, the ZKML and the OPML, they are both verifiable and also trustless in the assumptions. So in terms of the actual product, we take the OPML into the product of our ORA on-chain AI Oracle. So how ORA on-chain AI Oracle works is that feature-wise, it enables AI inference on-chain. And any smart contract can call this on-chain AI Oracle for AI inference result. And you can see from here that any smart contract can request an inference with the prompt and also the model ID. And then the on-chain oracle will return this result as a callback for the smart contracts. And note that on-chain oracle can be applied to any model thanks to the magic bring by the OPML. So this AI oracle is kind of different than oracles like price feed oracle, because like training price feed oracles, they are more like a push based oracle, but on-chain oracle is more like a pull based oracle. Like for example, it only returns the result to you if you initiate a result yourself. But price feed oracle is more like it will periodically push the result on chain. So with this approach, it's actually more customizable and also flexible, because you only get the result when it is needed for your application. With on-chain AI oracle, it is encouraging a new wave of on-chain AI demand and also applications. On-chain AI oracle can be benefiting the DeFi, NFT, and also on-chain game sectors. And we will also talk about some of the exciting ecosystem projects that are already being built in the future sites. So for building AI dApps with OAO, here's the basic info of interacting with OAO. So when we are saying building an AI dApp, we phrase it as interaction with OAO, because you need to build one of the smart contract, your smart contract, that is connected and interactive with OAO to request AI inference and get AI inference result. And then you, based on this smart contract, you will host your front end to like actually showing these AI results on your website or on your application. So it is something that we built for demo purposes. It is live at ai.ora.io, and we built one of the example smart contract connected to OAO called prompt.so. And it is an example built for anyone to interact with OAO directly. Because if you are not a developer, probably it will be hard for you to like locate all these buttons on the Etherscan to interact with an Oracle directly. So that we build this example smart contract, and also this front end connected to this smart contract that you can just like coding for AI results, very user-friendly way, and then having all those results on the website directly. And also another point on the AI Oracle ai.ora.io is that we are having our Prince program. So after you register inside our Aura.io website, anytime that you are interacting with ai.aura.io, you will get points, Aura points. So definitely check that out. And this is a more detailed step for how to build your AI dApp with OAO. So you can find this full tutorial in the docs.aura.io. And also inside this doc, you will also find a video tutorial so that all your questions can be resolved. And if you have more questions, you can just directly ask in our Discord channel. And so the basic workflow is basically build your own smart contract that's connected to on-chain and Oracle. And then build your front end that is connected to your smart contract. We'll also showcase some of the example in the later slides. So in terms of the actual development of the smart contract, it is these 3 steps. Basically set up your local smart contract, the dApp environment, and understand and using one of our template repository, and then connect your smart contract with ORA. So it's pretty much standard way to build a smart contract with external library. And then we're going to talk about some sectors of use cases. So the first one is AI-Fi, which is AI plus DeFi. Because before on-chain AI exists, or DeFi projects are just Solidity code or maybe a little bit off-chain code to building lending protocols or DEXs or like yield aggregators and all that. But right now we have this on-chain AI as a tool to compute for any of these computation modules. So we can actually use this AI as a smarter brain for this protocol to perform any DeFi operations. So for AI AMM, one of the things about AMM that everybody is thinking about but no one actually implements is dynamic fee. So because for implementing this dynamic fee, you need one agent to tell you that what is the market's condition and when do you need to switch up or switch down the fee of this pool. So AI on-chain AI is definitely fitting this role because they are very neutral and they are very smart and also they are verifiable. This kind of dynamic fee idea can be easily implemented with the AI-Fi concept. And also, let's pick another example like AI lending. So some of the key problem of lending protocol is that they are only allowing several assets to be lended or to be used, because they want to make sure that each lending pool is having kind of same risk, and also they want to manage the risk for pricing those assets. With the power of AI, actually you have this very powerful tool to price any asset, so that you can build a lending protocol which is permissionless in terms of taking the assets for the money market. So this is another cool use case that you can build in AI-Fi. And also we got the on-chain AI game. You can check more details in our blogs. We wrote a blog about on-chain AI game and all these details about AI as moderator, AI as governor, AI as NPC, and all that. So definitely check the blog for more details. But essentially, AI in on-chain AI game is matching with each other, because in the game industry, it is already heavily using AI. So basically, all the NPC, they are 100% AI in the current landscape. And so for having this on-chain AI, you can achieve kind of a fully on-chain AI game that the game itself is fully on-chain, and also the AI inside of it is on-chain. So it's a super cool concept that is centralized. And also we got the IMO, IAO, and inference assets. And these three are kind of more focusing on the crypto side, kind of focusing on the asset side. So these three concepts are basically tokenizing for IMO, it is tokenizing the model on-chain, because we are running this model on-chain, then it is generating on-chain revenue, and why not we just issue a token for it? So this kind of follows this mindset. So it is tokenizing the models on-chain. And IAO is similar. It is tokenizing the agent on-chain. And it's kind of tokenizing the fine-tuned model on-chain instead of just tokenizing the foundation model. And for the inference assets, we are making the inference result of the assets of the AI inferences as the assets. For example, you use the on-chain stable diffusion to generate an image, then this image can be, of course, used as the like NFT in terms of like ERC 721. And we will also talk about some relevant projects that work in this space. So these are the major sectors of OAO use case. And here are the major existing open source projects that we see using OAO. So the first one is 7007. So 7007 is the name is coming from the ERC of ERC 707, which is about verifiable AI generated token. And what they are trying to do is they are building the protocol for AI inference asset. So it's kind of like OpenSea, but all the collection, like the all the collection and all the assets, they are from the AI inference result, and then it is promoting the concept of inference as asset, and this is like a monetization of the on-chain AI era. And we also got Graviola. So Graviola is a pretty minimum project. So it's basically AIGC profile picture NFT project that with the on-chain stable diffusion. So the on-chain stable diffusion, they kind of having this kind of fixed prompt for all these logos or these thumbnails, and then they will generate this logo with the kind of the matching styles, so that these logos can be in the same category and also the collection. And you can roll new one NFT every 24 hours, and then collect, share, and sell the chain. So it is one of the earliest AIGC project that we see. So it is pretty neat, but super simple, but a pretty good example to look at when you are kind of want to build on the AIGC set of on-chain AI things. And also recently we've seen this project called the Landing Zone, and it is one of the AI5 project. And this Landing Zone project is working on permissionless lending with any collateral asset. So it utilize OAO to price the NFT so that they can be lended. And so this kind of like a very novel AI lending protocol powered by OAO. Currently, it is submitted to the hackathon, but the full code is not released yet. But we will having the builder to write a write-up for how this is built, so that we can so anyone can follow this path to build this kind of AI sector OAO power projects. And also we got the OAO-IE. OAO-IE is intent engine powered by AI. So you probably heard about the idea of intent. Intent is about like interpreting some kind of idea into an action. We write about intent before, and so intent is kind of like a Google search that you want to look for like a cookbook for a dish, and then you will having your intent that searching this like cookbook for the dish, and then you will locate that the actual recipe and actual cookbook for that. And another example of that is the order book exchange. So order book exchange is kind of also an intent based architecture that you having this intent of selling an asset at a given price, and then someone else, like a market maker or other traders, will fulfill your order uh, if they are matched, and also they wanna perform this trade. So intent engine, OLIE is also working on the intent side of things, and it is building the general intent engine for interpreting any human readable text into verifiable on-chain transaction. So why this is needed is because you are having this intent engine as an agent to perform transaction to you, so that you need to let it kind of providing a proof for you that it is not like doing anything suspicious. For example, if you like type in I want to buy the latest token on pump.farm, and then it won't like buy any like shit token that you don't want, and or any shit token that is not related to the actual intent. So you want this kind of verifiability in terms of performing this intent solving outsourced by this intent engine. It is also a pretty cool project because it's kind of outside of all these sectors, and we see this as a outlier, so that we take it to the talk today. And also, we got a repo called Awesome ORA, and we will show the link at the end of this talk. And it includes all the ideas that we came up with. So we got the general AI Oracle ideas, and also the AI-Fi ideas. And also we got some infrastructure ideas for the OL. So the infrastructure ideas will be more like dev tooling or the third-party libraries for OL. And AI Oracle ideas, AI-Fi ideas, they are more about the application side of things. Besides these ideas, we also encourage, we extremely encourage builders to come up with their own idea, because in terms of like building up this ecosystem, we actually see a lot of the best idea is coming from like people around us and also the builder community. So please don't be restricted on this list of ideas, and try to think of something creative or something shocking before you start a build. And here are all the crucial link for building on-chain AI Oracle. And feel free to take a screenshot or type these URLs into your chat, into your browser, to access those crucial links for building. And feel free to reach out to us in our Aura Discord and for any development related questions. So that's it for today. Thank you for having me, and please follow our Twitter and also join our Discord. Thank you.
Awesome. And through your presentation, I actually see some audiences asking questions. So I'll probably go through them like one by one. And for those of you who have any more questions, feel free to type it in the chat box, and Mammothsville will be answering those questions. So I see one from Rachel asking, how many percentage of the model need to be public in order to use the OPI?
Yeah, so we also have this paper for OPI, and OPI is actually, we doesn't have a restriction on how many percentage is required, because it is talking about this idea of separating this model and mixing ZKML and OPML together. So having this percentage will affect like how scalable your model is, because if we take the extreme case, if you have like 99% of the model in the OPML format
and then it is essentially like having kind of 100% of the scalability of the OPML model. And then like if you're having like only 1% of OPML, then you just get 1% of the scalability of OPML. But you will get like 99% of the model to be private. So it's all trade-off in terms of like setting this ratio and setting this percentage. But it is totally flexible, and anyone can build their own implementation with the same concept of OPAC.
Awesome. Yeah, I'll also get the link of the OPI research paper and share it in our communities later on. And I see another question asking, how long will the points program last?
So we doesn't have a deadline for the points program, but we will always running it, and we are adding like more new exciting tasks into it. Right now for the points program, you can get points from registration and also using the on-chain AI Oracle on the at ai.ora.io in the mainnets of Ethereum, Arbitrum, Optimism, and also Linea. And you can also refer others to the points program to earn more points. So this is pretty much the task we are having right now, but we will add more exciting tasks. So it is only the very start of points program, and we will see more exciting additions and more exciting updates into points program.
Awesome. And the other person was asking, what is the dream of this project? I guess Q is asking like, what is overall mission of Aura, and what Aura want to achieve in the crypto space?
Yeah. So the two major sectors of our product is the on-chain AI Oracle, which is for the builders, and also the other product is actually the IMO. For on-chain AI Oracle, we are enabling AI inference on any blockchain, so that any application can be powered by the intelligence of AI. And then for the IMO, we are actually tokenizing the AI models, and then this tokenization will bring value to the open source AI communities, because they always face the problem of like having no way to monetize and also gain revenues. But by this approach, kind of like issuing token as an asset, they will find a way to align all these ecosystem builders and also align with all the like scientists to continue to improve this AI model to make the open source AI better. And for the grand vision of Aura, we are actually connecting all intelligence. So if you think about intelligence, that like human being is an intelligence, is a kind of intelligence, and then the blockchain is another kind of intelligence, which is like a cryptography intelligence, and then AI is also another intelligence. So we are essentially connecting human beings with blockchain, with AI, and all these stuff together. By our first step is like bringing AI on blockchain, which is connecting this AI intelligence with blockchain. But this is more like a grand vision, like an end game vision for Aura. So yeah, that's pretty much our dream in terms of like the vision.
Awesome. And I know the time is getting close, and let's ask the two final questions that is on the chat box. The first one was asking, what's the difference between Aura's inference stack with Rachel's Infernet? Oh, this is a good one. I actually really want to know this too.
Yeah. So we see Rachel. We don't really see Rachel as a competitor because they are having this. They are taking kind of like a modular approach because they are kind of like proving system agnostic, because they claimed before that they are not working specifically on zkML or OPML or PML. They are more like a modular framework for embed any types of proving stack into their infinite. And this is the major difference, because at ORA, we value a decentralization and verifiability first, so that when we launch this product of on-chain Oracle, we natively empower it with the optimistic machine learning, without having like a very flexible approach of like probably having no security guarantee, or having like a very weak assumption for the machine learning inference. So I think this is the major difference in terms of how we value decentralization and verifiability. And also on the product side, we do see some similarity in terms of the on-chain Oracle and also the Infernet of Rachel. But in the dev experience, we seen a lot of developers saying that Infernet is like too complicated to use, because you need to like set up a lot of stuff. But for using on-chain Oracle, you just need to set up your smart contract and then connect that with the OAO, and then that's all you need for building an AI-powered like application. So this is the second difference. And the third one is, I think Rachel, in general, they are building a sovereign chain. I'm not sure what kind of chain they are building, but I'm pretty sure it will be kind of like a layer 1 blockchain, so that they will have their own layer 1 blockchain for all these AI inferences. But at Aura, we are building this on-chain Oracle that is launching on multiple networks. So first in March, we launched on the Ethereum mainnet, and then follow on, we launched on Optimism, Arbitrum, Manta, Linea, and also we got a lot of like exciting deployments in the next few weeks. So all these launches are in collaboration with the networks themselves. So we are like working closely with all these blockchains, so that we like enabling AI on their network, instead of like setting up our own layer 1 blockchain to compete with or blockchains. So by this approach, we are also ensuring that we are enabling AI on blockchain, instead of enabling AI by setting up our own blockchain. So these are the three main differences.
Okay, so last but not least, we have the final question of today. Is asked by Lauren, like GM, how can I train my personal can I train my personal agent through OPI?
Yeah, definitely. Because OPI is very suitable for these kind of agent models, or like fine-tuning models. Because if you think about it, that you have this foundation model, right? And this foundation model is fully open source already, because people want others to build on top of this foundation model for fine-tuning and all the community work. And then if it is already open source, then you can definitely running it with OPI. And then for the additional layer of parameter you added to the model with the fine tuning, you can run it with the zkML. And combining the both, you will of course use the same pattern and the same framework of OPI. So besides the paper, we also got one of the demo implementation by our chief scientist, Cassie. So I will send both the paper link and also the implementation to the chat so that you can take a look at it and probably like implement the like something similar.
Amazing, thank you. Sorry, I actually see another question. So can we do one last question real quick?
Yeah, of course.
Yeah. So Bobby was asking, I'm building a trading agent on Solana. Is Aura compatible with Rust?
Yeah, so right now, on-chain AI Oracle is not launching on Solana yet because it is not EVM compatible, and also like running a new set of like OAL smart contract will requires another process for auditing and all that. But we will try our best to launch on like a popular ecosystem like Solana. So Solana is definitely on our roadmap, and we will enable AI on Solana soon.
Hey, I think that completes our workshop today. And thank you, MSField, for hosting this workshop today with all those builders who are building projects